Ooh, ladies and gentlemen, it's time for Chapter 3. We will start out with learning about congruent figures. We're going to focus mostly on congruent triangles, but we will get into congruent polygons of all sorts of numbers of sides here and there, but again, mostly driven from congruent triangles here, and we'll be talking about them also in the XY coordinate plane, which will be super duper fun. Now, today I'm eating a wonderful lunch here as I make this video for you. It's a little bit of quinoa from the Costco, members only, with a little bit of pesto, also Costco, members only, and chicken from the Costco. Yes, you guessed it, members only. So it's quite a delicious little blend of things, and yeah, time to do some math. So congruent polygons, two polygons, sided figures, right? It could be 3, 4, 5, 6, whatever, on up to a bajillion and beyond, are congruent if their corresponding corresponding parts are congruent. So their corresponding angles are congruent and their corresponding sides are congruent. So in general, one would fit right on top of the other, perfect fit, right? Or you could also think of it as, one way that I like to write it is same size, same shape. And you'll hear a lot of people say that when they're talking about congruent. You know, especially if they're at like dinner, you know, the dinner party, you might say, oh, congruent polygons, yeah, same size, same shape. I mean, it happens all the time. On the football field on Sundays, you know, coaches are like, hey, bro, congruent, same size, same shape. Yeah, you'll see. Just read the lips, okay? You can't always hear it. All right, so all we want to do here is identify and name the congruent triangles. Now, you got to be very careful when naming these, and I'm going to give you some tips as to how to do that. So let's first look at the left side over here. We got triangle ABC and we got triangle SRD. Now, is that necessarily the correct way to list them? Let's see here. If I got triangle ABC, I got to make sure the corresponding sides and corresponding angles line up with each other. So I like to write down one triangle first, and then which angle corresponds with A? Well, D over here has one tick mark just like A over here had as well. So start with D. Well, then which one has two tick marks? Because B over here has two tick marks. That would be R. And then the last one will line up with C. You can also see from the sides, it's quite the loud bell, halfway through lunch, children. So you can see that the sides also match up. If I'm looking at AB, that should match up with the one tick mark, RD, DR, perfect. And if I have BC, BC should have two tick marks with RS. RS, boom, two tick marks. And then AC has three, so that should match up with SD, boom, right there. Cool. All right, so that's in the right order. I use the angles to do that. It's a little bit quicker than looking at the segments, but you don't always have that nice convenience. Sometimes you have to use the segments as well. So let's take a look at this other one over here on the right-hand side. Now here I'm giving you all the congruent marks. Now that's not always going to happen as we start to prove triangles congruent, but for now we're just seeing how to write the congruent statements. So again, I'm going to just write one triangle out, okay? If my pen, there we go, now it writes. So let's go with LMN. LMN. Here's congruent to triangle. Well, which angle matches up with L? One tick mark, that's Q. Two tick marks for M, that's going to be P. And then our last one is N. Excellent. Hey, quick question for you. If we didn't have this written here that those two angles were congruent, would you be able to tell me that they are? Oh, heck yeah. They're vertical angles, baby. Woo! That's right. And those are things you're going to have to do when we start proving triangles congruent. All right, so once again, we got one more example here. Identify the congruent triangles and their 6 congruent parts. Now, we're not going to identify all their 6, or I'm not going to write them down. But let's at least start with the triangles. So I've got triangle. I'll write down ABC, and then let's match up those corresponding congruent parts. Well, what corresponds with A? Angle D does. How about with B? And we're talking about this portion of angle B. That would be C actually does that. Okay? This part of the triangle. Okay, and then lastly, we have B for this one. That one's a little weird how it's like kind of like one triangle is part of the other and it's turned around. It's a little confusing. So be very careful when you're writing these out. Take your time with it. So Some congruent parts. Well, we've already kind of gone through that. We got AB is congruent to DC, right? Because these two are indeed in the same place. They're corresponding parts, so they are congruent. Angle BCD is congruent to angle CBA. All right, and we can do that all day. Okay, so that's just a couple examples of the congruent parts. One thing I do want to mention, though, if I didn't have this written down here, or the 3 tick marks for BC, could I say that BC is congruent to BC? Any thoughts there? I mean, anything should be congruent to itself, right? My goodness, we have a property for that, children. So this is called the reflexive property. And I often like to call it the common sense property because, something's going to be congruent to itself. So BC would be congruent to BC. I think that was actually what we had on that last diagram. This also applies to angles. It's not as frequent, but I could say angle A is congruent to angle A. However, this is one of the most misused properties in all of geometry, so be careful when using it, and I will point out some mistakes along the way that many students make, and also because I can see the future, okay? But reflexive property, jot that bad boy down. Any segment or any angle is congruent to itself, and it is actually useful. So here I've got a congruent statement that says triangle DEF is congruent to triangle GHI. We got 4 questions on here. I'm not even going to draw this out. I'm going to use my congruent statements to help you with this. So here we've got which segment is congruent to EF. Well, EF, that's the last 2 here, right? So HI would be that congruent segment. So HI. Hi. Next, which angle is congruent to HIG? Well, if it's HI and then G, use that same logic over here, EF, then D. Angle EFD. You could also say DFE because it has the same vertex, right? That's okay. Which segment is congruent to GI? Well, it's the first and the last. Same with the other triangle. DF. And then lastly, is FE congruent to HI? Does the order matter in which I list a segment? No. Order just matters with rays. So in this case, yes. Hashtag America. Awesome. Good stuff. This will be very, very helpful later on when we go beyond even proving triangles congruent. Oh my goodness, there's just always a beyond. We go above and beyond in honors geometry, children. All right, so we're going to do some coordinate geometry because, what's math without a little graphing, right? Love me some graphing. I'm going to plot some points real quick. We got -4, 0. I got to count on the screen without touching. So that is P. And then I've got 3, 5. So 3 up 5 is S. And then T is 5, 0. Okay. Now it says if triangle STP is shifted 3 units down and 2 units to the right, find the coordinates of P prime, S prime, and T prime. They're just saying the shifted points, right? So they use a prime or double prime or whatever to show that a transformation has happened. I'm going to make this into a triangle. And then let's plot the other one. So we went 3 units down and 2 units to the right. So here's P prime, 3 units down, 2 units to the right. That's S prime. And then 3 units down. Oh my goodness, I'm off the graph. I'm panicking, but I'll be okay. And there's T prime. So I've got another triangle. My question to you is, how the heck does this relate to what we were just talking about with congruent triangles, or congruent polygons for that matter? Well, how about this? Is the blue triangle and the red triangle, do they have the same angles still? Do they have the same side lengths still? I don't care what the side lengths actually are. I'm just saying, are the side lengths still the same? Yes, they are. They're just in a different position. So are these two triangles, PST and P prime, S prime, T prime, are they congruent triangles? Yes, absolutely they are. Okay? And I'm pretty sure you guys can figure out your coordinates, but let's just jot one of them down. That would be, what, 5, 2? right? And if I look at this guy, let's see here, we said 3 units down, right? So that would be changing my y coordinate. 3 units down from 5 is 2. And then 2 units to the right, well, that's adding 2, so that's how we go from 3 to the 5. Cool? All right, we can do that all day with the rest of them, but I think you guys can handle this, finding your new coordinates. All right, so we got the same points, but this time we're saying triangle STP is reflected over the x-axis. Write the coordinates of P prime, S prime, and T prime. Well, if I'm reflecting over the x-axis, that is this line right here, right? So if I'm going to do that, S prime is going to be popping all the way down here. Now, oops, I should do that in a different color. S prime, America, red, white, and blue. So where's T prime going to be? Well, it doesn't move. How about P prime? Also doesn't move. It's on the line of reflection, so it can't really move at all. But I've got, once again, a triangle congruent to the one that it just was. It just happens to be reflected down. All right, it's a vertical reflection or a reflection over the x-axis. You can really describe it in either way. Okay? And let's take a look at our coordinates here. So we said P and T didn't change, but S did. S prime became what? Oh, that's not an eraser. There we go. What's S prime now? It would be 3, negative 5. So when I reflect over the x-axis, the y-coordinate went from, or changed its sign, right? It went from positive to negative in this case. Interesting. Let's see what happens when I reflect over the y-axis. Alright, so we got the same triangle again, but this time I'm reflecting over my y-axis. That guy right there. So when I do that, let's see here, P is going to reflect over and become this point right here, which is P prime. It's 4 away on the left-hand side, now it's 4 away on the right-hand side from that vertical green line, right, my y-axis. T is going to pop over here, and S come over here. Mine, you know, I'm taking a look at my distance from that line. That's how I do that reflection, right? Okay, so once again, I still have a congruent triangle. It's the same triangle, it's just been reflected over. Right, but what happened to my coordinates this time? Well, S prime has now become negative 3, 5. The 5 stayed the same. T prime, can't really write it next to it with a lot of room, so I'm going to put it above it. T prime has become negative 5, 0 instead of 5, 0. And then P prime has become 4, 0 instead of negative 4, 0. So now it's actually my x-coordinate sign has changed. So when I reflect over the x-axis, my y-coordinate sign changes. When I reflect over the y-axis, a horizontal reflection, my x-coordinate changes. Reason being, if you think about it, well, when I reflect over the y, it's a horizontal movement, right? My horizontal coordinate is my x-coordinate. When I reflect over the x-axis, like I did in the last one, that's a vertical movement, so my y-coordinate changes. That's fun stuff. Same triangle again, but this time it's rotated clockwise 180 degrees around the origin. Write the coordinates of P prime, S prime, and T prime. So there's a few ways of thinking about rotations. So if I'm going to rotate S, or sorry, let's start with S. All right, so if I'm going to rotate S 180 degrees clockwise, that means I'm rotating it over. It's going to end up in my 1, 2, 3rd quadrant. This is my quadrant 3, okay? So S is going to rotate around and end up in quadrant 3. There's a couple ways of thinking about that. One would be to think about it as okay, I'm going to go down 5 and over 3 to the origin. So I'm going to go over 3 and then down 5 to get to my new location. That would be the exact spot. That is absolutely terrible. My goodness. There we go. Okay, so that is my S prime. Cool. All right. Now, another way you can think about it is actually as a double reflection. I would reflect over the X and then over the Y. That's only for 180 degree rotations though, all right? Let's take a look at P. For P, if I'm going to rotate 180 degrees, clockwise, I end up right over here. Right? If I think about that as a rotation, whee, pew, right over there. And then for T, I end up over here. Cool. So let's connect these dots, and I think it will become a little more clear when we're looking at this as a shape. But if I were to rotate this triangle around that origin right there, and I were to turn it, I was almost about to try and turn it with my hand, but I can't really do that. If I were to turn it, then it would end up in that position there in that orientation, which is actually also a double reflection. Okay, let's look at our coordinates. S becomes, let's see here, -3, -5. All right. T prime is still, or is going to become -5, 0, and then and then S prime. Wait, sorry, that's P prime. My goodness, sorry guys. P prime becomes 4, 0. Now it's really only apparent on this one because the other two have zeros. But what happens is both signs change. All right, both signs change. So to quickly recap that, if you're reflecting over the x-axis, the y sign changes. If you're reflecting over the y-axis, the x sign changes. And if you're doing a 180-degree rotation, which is the same as a double reflection, both signs change. Woo! There's our rules, America. All right, and there's our H-dubs, 1 through 5 all. You may want some graph paper, but you can also do it with those 3 rules.